Hi guys, welcome back. In this video, we'll be treating this question. Now, this question was extracted from 1985 UTME past question 6. So the question goes thus: if a car starts from rest and moves with a uniform acceleration of 10 meters per second square for 10 seconds, the distance it covers in the last 1 second of the motion is. Now, the very first mistake anyone make when attempting this question is using this 10 seconds directly and getting this answer as their final answer. Whereas that would have been wrong. Now, so the first thing we do is what? Draw a diagrammatic representation of this question. So I said a car starts from rest. So that means the velocity here is 0 and then moves with a uniform acceleration of 10 meters per second square. So it moves uniform acceleration of 10 meters per second square for 10 seconds. For 10 seconds. Then the action is to calculate what the distance covers in the last 1 second of the motion. So after having a diagrammatic representation of the question, the next thing we do is what? That are the parameters we are given. So the first parameters we are given is what? Acceleration. And then we're also given time. We're taking note. We won't be using this time directly. Put your question mark. Then what else? Don't forget, they said the car starts from what? From rest. So that means U is 0. So now, what are we looking for? We're looking for the distance covered in the last 1 second of the motion. Now, they're not asking us to calculate the distance it covers at the 10 seconds. They're asking us the distance is covered between 9, the 9 seconds and the 10 seconds. Take note, 9th and 10th. And every single time that you have 9th, 10th, something like ordinal numbers, you don't use those numbers directly. And you use a separate form of equation of uniform motion. But then before we get there are like two approaches to solving these questions. The first is you calculate this total distance covered for that 10 seconds, and then you calculate the total distance covered for 9 seconds. Simply asking us for what? The last 1 second. And the last 1 second is between what? 9th and 10 seconds. So after you've calculated the distance covered for the 10 seconds, the distance covered for the 9 seconds, then you subtract the two together, you also get your answer. Then another approach, which is the one that I always advise people to use, and that I myself use, is to reconfigure the equation of uniform motion. So now we already have all the values that are given, the parameters are given, the parameters we are looking for. And we already have the diagrammatic representation of the question. So what else do we do? Which topic is this question for? Motion. Which subtopic? Uniform motion. So now what do you do? Write out all the equations that you know pertaining to that topic. So equation of uniform motion. We have what? You have what? V equals to what? U plus T. You have S equals U plus V all over 2 times T. You have S equals UT plus half AT squared. And then you have what? V squared equals to U squared plus 2AS. So now this is the like untouched equation for information. Now every single time you have to calculate anything at all pertaining to uniform motion, and the time you are given is in is more like it's given in an ordinal manner, like first second, third second, second, fifth second, and 7 seconds. You cannot use this directly. You have to configure this to another form of formula. And it's not that hard. So let's say Tn is like the ordinal time that we're given. So it's like the nth second, like 10th, 7th, 8th, 9th, you know. So you will configure this to give you b equals u plus a open bracket tn minus tn minus 1. Now, what tn minus 1 means is that if tn was like 10 second, now tn minus 1 will be 10 minus 1, which give you 9. So in this case, it will be what? 10 minus 1 will be what? 9. So 10 minus 9. I hope you get that part. So let's do the same for this. So we have s equals u plus v over 2 tn minus tn minus 1 of s equals u t minus tn minus 1 plus half a tn squared minus tn minus 1 squared. Then this remains unchanged. Okay now. So looking at all the parameters we are given and looking at this equation now, which of this equation are we to use with this? Yeah. So what? You select your values. So you have that's triple. You have s equals your u is what 0. So everything here will be 0. I don't want to waste much about time. Let me just put it 0 in bracket 10 plus tn in this case is what 10th. Now in this question we were not given 10th directly. We're not given like what is the distance covered in the 10th second. They twisted the question a bit that the distance covered in the last 1 second of the motion. Now, the last 1 second of the motion is the 10th second. So what they asked me is that the distance covered between 9 and 10. So let me use this diagram for example. So let's say this at this point, you have t to 0. At this point, you have t to be 10 seconds. So what they are asking you to do is to calculate the distance covered in the last second. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the last 1 second of the motion is what? Between here and here. And that's what we are asking you for. So, and if you look at it very well, it is more like the distance covered in the 10th second. What's like distance covered within this point. I hope you get that. So that's why we're using 10. So you have 10 minus 9. 10 minus 1 is what? 9 plus half. Your a is what? Is 10. Tn squared, that's 10 squared, minus tn minus 1 squared, that's 9 squared. So you have s to be equal to half times 10. 10 squared is what? 100. Minus 9 squared is what? 81. So s is what? Half times 10 times 19. So you're going to get what? 95 meter. So that's the answer to the question. So don't forget I said that there are two approaches to solving this question. We can either calculate the total distance covered first by the for the entire journey, which is the 10 seconds. And then you calculate the distance covered by the following second before that second, like 9 seconds. That's what to be. Instead of having, so to calculate the total distance covered for the whole cycle, which is 10 seconds, it will be what? S equals to UT plus half times 10 times 10 squared. So that'll give you the distance covered between here and here. Now, then you calculate the distance covered between the following seconds, like the previous seconds. Yeah, let me do that. The previous second, which is what? 9. So it will be S equals to UT plus half. A is your 10 times 10 times C squared, which is what? 9 squared. And after calculating that value, then the you subtract this from the entire stuff so that you only get what this fraction that is here. How to get that? So it's not just limited to just 10 seconds, 9 seconds, 8 seconds. They can give you different order. It can be 11, it can be 12, it can be 13, it can be 15. How can get that? Or should I try and attempt it? Let me just quickly attempt. Let me attempt that. So assuming we are not using this modified formula now. So you have S equals U0 times T. Let's calculate for the 10 seconds first times 10 plus half times A times 10 squared. So this will give us 100 times 100, that's 1000. 1000 times half, that's 500. So that's for the entire journey. So for the previous second, so we have S equals 0 times 10 plus half times 10 times 9 squared. So S equals to half times 10 times 81. So S will be equal to times 10. It's 10, half of it, 405. And then you go ahead to subtract this from this. You want to have 500 minus 405. And that'll give you what? 95 meters. The same as what we got when we use this. But you know that this is like faster, very quicker. But then if you try to use the one that you know that you won't make a mistake when you try to use it. And for me, I think this is faster. Because you're writing an exam and you are trying to save time. So it's the best way to understand the faster one. But then in case you can record that particular one, and it's very good for you to have two options or tell you approaching questions. So that will be all, guys. So I'll drop a similar question in the comment section. So try to attempt it and drop your answer. I'll tell you whether you're right or wrong. And I'll probably make a video explaining it. If I notice that I probably a lot of people get it wrong. So see you guys in the next video.